We have now seen two different methods for solving systems of linear equation, the graphing method and the substitution. The method we will use here to solve systems of equations is called the addition or elimination method, depending on the book you're using. Recall from the video on solving systems of linear equations by graphing, a system of equations consists of two or more equations. In our example 1, we have two equations. The solution of a system of equations in two variables is an order pair that is a solution to all equations in the system. So the solution, it's an x and y. An order pair that all equations have in common, the point where all equations meet or intersect. So let's cover the steps for this method and solve example 1. The first step is that we must line up the variables. Step 2, select a variable to eliminate and cross-multiply to create opposite coefficients. Opposite means that one has to be positive and the other one has to be negative. Then we combine resulting equations and solve the new equations. And finally, substitute the value found in step 3 in one of the original equations to find the solution. So let's begin example 1. First, our variables have to be lined up. If you notice in our first example, the variables are already lined up. We have x's, then y's, then the equal sign. So we're going to move on to step 2. We're going to select a variable to eliminate and then cross-multiply to create opposite coefficients. Now we can select any variable we want to eliminate. It doesn't specify if it has to be an x or a y. For this example, since I know that the coefficients have to be opposite in sign, one positive and one negative, I'm going to select the y's to eliminate because I already have them opposite in sign. The first y is positive and the second y is negative. So then all I have to worry about now is a cross multiplication. The way that we cross multiply is the following. We're going to look at the coefficient of the y in the second equation, and that is the value that the first equation will be multiplied by. So the first equation is going to be multiplied by 10. And then we look at the coefficient of the y variable of the first equation. Remember, the y variable is the one that we decided to eliminate, and that's what the second equation is going to get multiplied by. So let's begin the multiplication. 10 times 2 will be 20x. Then 10 times 3 will be 30y. And then 10 times 16 will be 160. But since the 10 is positive and the 16 is negative, this will be negative 160. Let's multiply the second equation. 3 times 5 will be 15x. And then 3 times 10 will be 30y. Since the 3 is positive and the y is negative, this will be a minus, equals, and then 3 times 30 will be 90. All right, so far we have done step 1. We lined them up. We've just finished step 2, which is we cross-multiply to create opposite coefficients. Now we need to move to step 3, which says that we have to combine these resulting equations and solve the new equation. So let's combine them here. I'm going to combine here the x's. I have positive 20x's and 15x's, so 20 and 15, that will give me 35x's. Now I move to the y's. Since the y's have different signs, we subtract. So 30 minus 30 will go to 0, so the y's get eliminated. And on the right side, I have negative 160 and 90. Again, different signs. We subtract and keep the sign of the largest, giving us negative 70. So we have almost completed step 3. All we did was combine the resulting equations. We still need to solve the new equation. So I'm going to bring my equation up here because I ran out of space. So this is 35x is equal to negative 70. Now the way we solve equations is the following. We're going to find where x is located. In this case is on the left side, and we notice that that x is being multiplied by 35. So we do inverse operations. The opposite of multiplication is division. So I'm going to divide both sides by 35. Then from left to right, 35 divided by 35 will be 1x or just x. Now be very careful. Down here we were adding or subtracting, we were combining the results. So 30 minus 30 went to 0. In this one we are dividing. So 35 divided by 35 will be 1x or just x. On the right side I have negative 70 divided by 35. Well, 70 divided by 35 is 2, and because they have different signs, the x value will be negative 2. Now be very careful here. This is not the final result. Remember, the solution is an x and y value. This is an order paired. We only found the x's. We still need to go find the y values, and we do that by completing step 4. Now step 4 says that we're going to take what we found in step 3 into one of the original equations. So I'm going to select the first equation. It doesn't really matter which ones you select. You can select the first equation or the second equation to do the substitution. So I'm just going to select the first one so that I have 2x plus 3y is equal to negative 16. And then I'm going to replace this x with a negative 2. So everywhere I see an x, I replace it with negative 2. I bring down the rest. I have a multiplication by 2 before the x. And then I have all of this after. So let's multiply. 2 times negative 2, that would be negative 4, plus 3y is equal to negative 16. We need to solve this equation. So I notice that my y value is again on the left and is being multiplied by 3, and it has that subtraction by 4. Now you might be asking, how do you know if it's subtraction if this one has a plus? Well, when we add negatives, the operation being applied is subtraction. Now remember, there is an order for solving equations, and the order says that first we move anything that is being added or subtracted. So that means that I'm going to add 4 to both sides of the equation first. From left to right, negative 4 plus 4. Different signs, we subtract. 4 minus 4 is 0, leaving me with 3y is equal to, on the right side, I have minus 16 and a positive 4. Different signs, so we subtract and keep the sign of the largest, so that would give me 12. Finally, remember, we still need to get rid of that 3 that is multiplying y, and we do that by dividing. So from left to right, 3 divided by 3 is 1y, or just y. And on the right side, negative 12 divided by 3. Well, 12 divided by 3 is 4, and since they have different signs, this will be negative 4. So now we have the x value and the y value. That means that our solution is going to be negative 2, negative 4. Now you can go back to video for substitution and you will see that this is the same solution. In example 2, they're asking us to solve the system by addition or elimination method. Remember, the steps are to line up the variables, to select a variable to eliminate by cross multiplication to create opposite coefficients, combine the resultant equation to solve them, and then come back and substitute the value found in step 2 in one of the original equations. However, I see that our equations are not lined up. If you notice this time, the x's are on the right side of the equal sign for the first equation, And on this one, the x's are on the left side of the equal sign for the second equation. So let's start with step 1 and try to line them up. The way I'm going to line them up is I'm going to move this x's on the right side to the beginning of the first equation so it can line up with the second one. So step 1, line up. I'm going to bring the first equation, y equals minus 8 plus 7x. And since that 7x is a positive, I'm going to subtract the 7x from both sides. So from left to right, these two cannot be combined. They are not like terms. It doesn't really matter if you write the y or the x's first. However, since the second equation has the x's first and then the y's, that's what I'm going to do. I'm going to put the x's first and then the y's. So I'm going to have minus 7x, bring down the y. Since it's positive y, I'm going to write a plus, equals, on the right side I have that minus 8, and the 7 minus 7 will go to 0. Now let's bring the second equation to line it up. So that is 3x minus 3y is equal to negative 12. So we've completed step 1. Now we need to select a variable to eliminate by cross multiplication, making sure that they are opposite coefficients, one positive, one negative. Now since both of these, the x's and the y's, are already opposite in sign, you see how the x's have a negative and a positive, and then for the y's I have a positive and a negative. So this time what I'm going to eliminate will be the x's because we eliminated y's on the first example. So now I'm going to try the x's. Remember what we do here is the first will get multiplied by the coefficient on the second, so that is a 3. And then the second gets multiplied by the coefficient of the first. I'm only going to take the number, not the sign. I have 3 times negative 7x, that would be minus 21x, and then 3 times y, that will be 3y, and then 3 times minus 8, that would be negative 24, different signs. Then we move to the second, 7 times 3, that would be 21x, 7 times minus 3, that would be negative 21y, don't lose the equal sign, and then 7 times negative 12, that would be negative 84. So we just finished here, step 2. Let's move now to step 3. And this is to combine the resulting equations. So let's combine them. From left to right, minus 21 and positive 21. Different signs, we subtract. So 21 minus 21, it will go to 0, gets eliminated. Positive 3 and minus 21, different signs, we subtract. We keep the sign of the largest. So this will be negative 18y. And on the right side, I have negative 24 and negative 84. Well, this is the same sign. That means that we add and keep the sign, giving us negative 108. We are not done. We're going to notice that our y's are on the left side and they're being multiplied by this negative 18. So we're going to divide both sides of the equation by negative 18. From left to right, negative 18 divided by negative 18, that will be 1y or just y. And on the right side, 108 divided by 18 is 6, and the negative will make that a positive. Okay, so now we solved the equation. We have completed step 3. We're going to move to step 4. We're going to substitute what we found in step 3 in one of the original equations. So let me bring out here step 4. Since I used the first equation in example 1, I'm going to use the second equation here in example 2. So I have 3x minus 3y is equal to minus 12, and I am going to replace these y values with 6's. So right here on the y, I replace it with a 6, and then I bring down the rest. So then this will give me the 3x minus the 3 is equal to what's before the y's and then what's after, negative 12. We begin by multiplying. 3 times 6 will be 18. Bring down the rest. Remember, first we move anything that is being added or subtracted. In this case is that minus 18. So I'm going to add 18 to both sides of the equation. From left to right, that gives me 3x. Well, negative 18 plus 18, different signs, we subtract. That goes to 0 equals, on the right side I have negative 12 plus 18. Different signs, we subtract and keep the sign of the largest. In this case will be 6. Don't forget, we still need to divide by that 3 multiplying the x. So I divide by 3 both sides of the equation. 3 divided by 3 will go to 1. So I have 1x or just x. And on the right side, 6 divided by 3 will be 2. So now that I have the y value and the x value, I can say that I found the solution. Remember, the solution is in x and y, an order pair. So I write the x value first, that was 2, and then the y value second, that is 6. So this is the solution to example 2.
Thank you so much for watching, and I'll see you in the next one.